Welcome, everybody. This is the second talk of our morning session, day 3 of the iRODS Consortium's User Group Meeting 2020. This is Brett Hartley from the Wellcome Sanger Institute in the UK. He's going to talk about creating an iRODS zone with Terraform. Go, Brett.
All right, thanks, Terrell. Good morning, afternoon, whatever it is for you. My name is Brett Hartley. I'm a systems administrator at the Wellcome Sanger Institute. Over the last year, I've had the chance to work on automating the process of making iRODS zones in a known state. Most of you know my colleague, John Constable, and by proxy, the Sanger. But for those who don't know us, we're a genomics institute based just outside of Cambridge, funded by Wellcome. We've been using iRODS at the Sanger for 9 years. A year ago, we decided we needed to upgrade both iRODS and the operating system on the entire estate. Not an easy feat when the estate is over 100 machines across 12 zones serving 23 petabytes. So when we're doing an upgrade, we need to do some testing. Often it's the largest part of the upgrade, and we need somewhere we can run the upgrade to see what happens. For this test to be beneficial, the environment needs to be similar to the environments which need to be upgraded. So what environments could we use that resemble our production zones? Well, nothing resembles our production zones quite as closely as they themselves do, but our production zones are just that, production. So we can't do anything to them which might be service affecting without having tested it. So that rules out testing on production. So what about our dev zones? After all, that was one of their original purposes. Over the years, these zones have mostly been used for client-side testing, which began to limit the amount of server-side testing we could do, and meant changes required arranging downtime and having a rollback plan. Because part of the upgrade process from 4.1 to 4.2 is to change the database schema, populate a number of new columns, and empty a few more, rollback is not quite as easy. The quickest approach normally involves restoring from a database snapshot. Then there's the issue that our test harness takes some time to run, which adds to the downtime window. If we have to fiddle a few times and we have to run the test harness multiple times, then the downtime window could end up being quite large. And therefore there's quite a lot of risk involved. So we'd rather have a test environment which we could play around with without affecting anyone else's work. So maybe we shouldn't use a dev zone either. So what should we use? Could we maybe take some old retired hardware and repurpose it? Well, we could if we could find the hardware. But then what if we want another one, for example, to test in Federation? We only have a certain number of old retired machines we can repurpose before there just aren't anymore. Could we maybe buy some new kit to test the upgrades on? Sure, but again, we have the issue if we want more than one zone. So what about using a cloud, either a public cloud or the private cloud we have on site, OpenStack? This has the benefit that we can have any number of zones limited by our willingness to spend money and by our OpenStack capacity respectively. If we choose to use a cloud, though, then we need to be able to free up the resources when we're not using them to save money or capacity, respectively. And if we're doing that often enough, then we need to be able to cleanly stand up a new zone with minimum human interaction. There's plenty of infrastructure as code products out there to solve this problem, but the one I'm most used to is Terraform, so I chose to use that for this. So before I go into all the problems that I had to solve, I'm just going to give a brief intro on OpenStack and Terraform at Sanger. So we have an OpenStack deployment on site with just over 100 compute nodes, which gives our users access to compute environments where they're allowed root to complement our HPC environments quite nicely. Many of our user groups then face issues around consistent deployments, and some of those groups use Terraform to make sure that those environments they deploy are consistent. As a result of some groups using Terraform, I've had quite a lot of chances to help them debug their issues, which has given me a decent bit of experience writing Terraform and a bit more experience debugging it. And it meant that a while ago, I wrote some templates to do some simple things like stand up an instance with all the required networking. Terraform allows us to deploy a specific set of resources and configure them exactly how we want. So for servers, this means we can run an arbitrary configure script generated at server create time. So now that we've chosen what we're using to write the infrastructure as code and what platform we're deploying it to, we have to actually write it. Thanks to the templating work I'd already done, I had somewhere to start from, but this needed to be adapted to handle the 3 different types of machines: the database servers, the providers or ICATs or IESs, and the consumers or iRODSs, and further to allow for variable numbers of providers and consumers. By default, we deploy 2 providers and 4 consumers split into 2 pairs to produce a replicate resource. In order to set up all 3 types of host, we need scripts which can configure them from an image in a known state. We start from images which already have the right 4.1.12 packages installed on to speed up deployment, but the scripts could be easily modified to also install the packages. The first problem we have to think about when we're attempting to get iRODS working on all the machines is that they don't know where all of the other hosts are. We have to tell them where they are. Normally we would do this with DNS, but this is a small short-lived test purpose, and DNS might not be entirely necessary because there are alternate approaches like etc.host or iRODS host config file. We have already used etc.host for similar things in production with issues with old operating systems. So that means we have to populate the etc.host entries properly, handling the database hosts, the providers, and both sets of resource servers, which means we need to know the list of IP addresses for all of the configuration scripts. In order to pass the IP addresses into the configuration scripts, we need to know what they are before we can create any of the hosts, which means we have to create the floating IP addresses before we create the hosts to avoid producing a circular dependency. Once we have this list of IP addresses, we can feed them into the configuration scripts and use blocks like this one to iteratively create the correct entries in etc.hosts. So the next problem, now that all the hosts know where they are and where everyone else is they need to actually be running iRODS, which means we need to run the setup iRODS script. So that means we need to configure the 4.1.12 providers and the consumers. But focusing on the provider first, we have to know what the iRODS username and group name, the zone port and higher port range, the vault path, the zone and negotiation keys, the control plane port and key, the schema path, the RODS admin username and password. And then we have to confirm all of those and fill in the database information, the host, port, table, username, and password before once again confirming. This example, lifted straight from the IDS provider configure script, uses defaults for all values except zone name and database host. It's worth noting this order is different in 4.2, and I've not yet done the work to find out the order, at least partly because setup iRODS only supports 1 provider for 4.2, see issue 4602, but the templates create 2 by default. So we've got iRODS running on all the machines. Now we just need to create all the resources, which we've decided to stick quite close to our production zones. So we have a top level route pass through to a replication resource to a pair of randoms, red and green, which each have half of the resources below them. Now, when we're creating the resources, the most obvious solution would be for each consumer to produce their own resources. This is fine for file system resources, but what about the coordinating resources? They have to exist before the file system resources do so that we can set them as parents at create time. That means that we either have to attempt to create them on the consumer before we create the file system resource, or we have to rely on the provider creating them first. This inherent concurrency causes issues as you try to build up layers and add complexity, so I went for the simplest solution I could think of. Strip out all the concurrency and have one machine create all the resources. So whichever provider manages to create the root resource will create all of the other resources. This means that each other provider only needs to handle the case where they get the error message that root already exists, and then they just stop. Any other error is an actual error and we should know about it. So how far have we got? I've done more upgrades than I can count on these tiny zones, and that's given me plenty of experience doing upgrades so that we've been able to do 6 upgrades on our production and development zones, and we've arranged for 4 of our smaller zones to be merged into larger ones. We also have plans in place to upgrade the remaining 2 zones. We've also upgraded or side graded every consumer onto Ubuntu 18.04 and have plans to replace every provider with new Ubuntu 18.04 machines. As everyone knows, however, just because there's an upgrade in the works doesn't mean anything else stops. We've added 7.5 petabytes to our zones this year and recently passed 30 petabytes in production zones. So this has given us other benefits. They're not immediately obvious, but here we go. The being able to deploy new zones quickly has given us the ability to produce a new type of user-facing zone, demonstration zones, which provide a set of plugins not yet available on the main zones for users to test their tools against. This allows us to quickly identify issues produced by interactions between users' tools and these new plugins, and significantly increases the rate at which we can improve our iRODS offering for our users, as well as telling us what tools our users are actually using. We're also benefiting from being able to test features and plugins much faster before offering them to our users. So as an example, we tested an SSL enforcing zone, found that it passed all of our tests. Then we're able to provide an SSL enabled demonstration zone to one group, who then agreed it was good enough for their development zone, where they were able to test at a large enough scale to give us the all clear to enable it for their production zone. This process probably would have taken 6 months on its own, but in the last 4 months, we've done all of that, even with our attention being divided by all of the other upgrades going on. Another advantage we've found is that we've been able to quickly find simple reproducers for issues we're finding. This results in the issues having a smaller bound and means that the resulting bug hunt doesn't have to cast its net quite as wide. These small reproducible zones have also given me the ability to test some ideas that had potential use cases, but needed to be proven right before they could be used anywhere, for things like file migration. Over the last 6 months, these zones have also allowed us to test integration of a few different plugins and features. As I mentioned, we have one production zone with SSL. That zone also now has PAM authentication, and we're working on rolling out NFS rods for another of our production zones. We're also testing metalinks, indexing, and evaluating the possibility of migrating our databases from Oracle to Postgres. So what comes next? I'm working on getting the Terraform templates into a generic form so they don't depend on bits inside of Sanger, and we'll put them on GitHub once I've done this. The plan is then to make the Terraform templates also able to install 4.2, either by handling the 4.2 setup script or by upgrading a configured 4.1.12 zone. We still need to upgrade the remaining 2 production zones, and once we've done that, we plan to enforce SSL on every production and development zone. Once all our production zones are on 4.2.7, we'll have to start looking at 4.2.8, and as part of that work, we hope to use Terraform to automate testing by creating a cluster, running a series of tests on that cluster before finally cleaning up behind itself by deleting the cluster. We also have a SAF cluster on site, which presents an S3-alike service, so we want to review the possibility of using the S3 resource plugin, both for temporary stopgap resources and for long-lived resources. I could not have done any of this without the rest of ISG helping me with OpenStack issues and taking over some of my day-to-day tasks so I could spend more time on this project. And I definitely couldn't have done it without borrowing some of John's iRODS knowledge. I've lost count of the number of times I ran into an issue, mentioned it to Terrell and Alan on our conference calls, and got an email with the answer if I didn't get it in the call. So I definitely need to thank them for being our primary contacts at Renzi and for not just screaming and running away at some of my ideas. But it wasn't just the two of them. Over the course of the upgrades, we must have been helped by most of the iRODS team. So thanks to all of you. Questions?
Very good. It's fun to see it all in one place. Yeah, I saw a secret 331 mentioned in one of your slides. You moved through it pretty quickly.
It wasn't secret. You knew about it.
We
that
do
was
have
a year ago, and it's now 4.2.7. It was the first production zone to be 4.2.7.
Yes, it was. I know it well. We do have a question from Samuel at CNES. He noted that your setup script was a .sh, and I know the answer. Why is it a .sh instead of a .py?
So the in 4.1, the setup script is a shell script, and in 4.2, it's a Python script. We were installing 4.1 so that we could do a 4.1 to 4.2 upgrade, so it had to be the bash script.
That's right. So it's not a custom thing that you have.
No.
Excellent. Let's see. Tony Edgen at Cyverse is very excited to see all of your Terraform work on GitHub so he can play with it. Maybe it's already there?
It's not already there. I need to do the work to remove all of the references to bits inside of Sanger before I can put it on there.
Sure. Does anyone, is Mike Conway, let's see if he, I'm sure he doesn't have anything to say. Mr. John Constable, do you have any questions? You've always got smart things to say. Do you have any questions for Mr. Brett? Let's see. Otherwise, so Alan King asks, is the testing harness going to be available for, okay, so it's the same question. he wants to know when this harness will be available.
Yes, we've not even started writing the harness yet. We have a small harness at the moment that takes some time. We want to have a full thing that creates tests and then deletes, and that will take time to write. So probably, but it doesn't exist yet, so I can't give it to you, sorry.
Not a problem. Are there any other questions? We have an incoming question from Jason Kaposki. Let's see. Is configuring policy part of the framework?
So our setup scripts create all of the rule files, but we just use the same rule files as we already have on production. They're not particularly large. We don't do very much with rules.
And the rules that you do have, I think, are themselves versioned over time, but they are not changing very often.
Yeah.
Right. I think there's a couple other people typing here for a second. We have a few more minutes, so we're not crunched. So in terms of starting from scratch again, would you choose this path forward? I mean, using Terraform seems to have been quite productive for you.
Using Terraform has made it much simpler to actually test all of the edge cases that we could think of. Obviously, we didn't find all of the edge cases because we're in a lot of corners that we forget we're in sometimes. So yes, we definitely would have done something like this. It might not have been Terraform, it might have been some other solution, but it was definitely useful to have done.
Mm-hmm. All right, so I think that might do it. Thank you, Brett. Great talk, appreciate it.
Cheers.